Hey guys, I'm Will from Tested.
And I'm Norm from Tested.
Norm and Chan, you have a lot of toys in front of you today.
Today is really exciting. On Tested, we've talked about 3D printers for a long time. We were early adopters of 3D printers. Behind Will, one of the second 3D printer we actually built. That was the second one.
No, that's the first one. The second one doesn't fit on the shelf.
That's the first 3D printer 4 years ago that we built.
It's the MakerBot Cupcake. It was like $1,400 at the time. It wasn't very good,
right?
To be perfectly frank.
Well, you know what's also not very good?
3D scanners?
The very first generation of 3D scanners.
Well, hold on.
Home 3D scanners.
Yeah, I was going to say, you can spend a truly obscene amount of money on a 3D scanner that does all sorts of crazy stuff like, scans the object and then applies what is imported into CAD, projects it on top of the objects. You can see exactly where everything matches up. This is not that.
Right, just like when 3D printers really hit the home market, the hobbyist market 4 years ago, 5 years ago, 3D printing technology, FDM, fused deposition modeling, had been around for a long time. Except hobbyists now with software, with the CAD designs, they can build their own and allow people at home to try it out. At the point
at which the Cupcake came out and early rep designs were being posted and shared, the gap between a $25,000 commercial 3D printer and a $1,000 home 3D printer was very wide and dramatic. Yeah. That gap has closed dramatically. So if you're talking about the same style of printer, the FDM, which you mentioned before, then those printers have gotten better and better and better until the difference between an expensive printer and a cheap printer is speed and maybe fine detail and the amount of time you have to noodle with it, not the quality of the final print or the ultimate print you can get out of it. 3D scanning.
3D scanning, at least for home consumer 3D scanning, uses, again, there are different types of 3D printing technologies, there are different types of 3D scanning technologies. On the very manual end, we've done things like photogrammetry, where you take actual digital photo images, composite them in software, and the software does a lot of the magic. MakerBot, the makers of that Cupcake 3D printer, they have their own 3D scanner. It uses the same technology as this one. This is the Matter and Form. It was launched as an Indiegogo project a year and a half ago, and they built themselves as a affordable home 3D scanner, even portable. Now, it was $450.
You should show this. This thing is neat. I love the way it folds open and closed.
Yep.
Like if you take the calibration block off of the turntable there, it becomes a thing that is much more portable than any of the 3D printers we've used.
From an industrial design standpoint, it's neat. It's clever. Like you pop this down. This actually is the foot that goes down here.
Is there cord storage inside it someplace?
No, the cord storage is best inside.
Goes in there. Okay.
Inside there. And the principle that this 3D scanner works under is the same principle as the MakerBot 3D scanner, in that it uses lasers and cameras. If you look here. This is, as anyone who's built a 3D printer could tell, just a Z-axis with a stepper motor. And on the stepper motor, inside this carriage here, is two lasers, so a laser there and a laser there, and at the center is a camera.
What kind of lasers are they? Like red lasers, blue lasers, green lasers?
They're red lasers.
Just red lasers. Seems old-fashioned.
Oh, it is. And on the platform, so this is the scanning platform, you can put objects up to about 9.5 inches tall, 9.8 inches tall, and the diameter is what matters. So it can be square, it can be circle, but about 7 inches in diameter.
So it needs to fit inside that turntable.
Yeah, I would call this a loaf of bread, at least bigger than a cupcake scanner. And what happens then is this turntable rotates several degrees, or very slowly, and two lasers hit the object. So for example, I'll put this little Android figure there. So hit the object, and then the camera will read point dots, like a dot cloud. So 2,000 dots per scan. So
it's literally just looking for places that it reflects back to get the distance, the time it takes a piece of light to reflect back at any given time. So are the lasers zooming back and forth, or is it just relying on it to rotate to hit in the same place?
It is purely relying on this turntable to slowly rotate.
What happens if you don't get the object centered perfectly?
Then it doesn't work.
Okay.
Then it gets confused. And there you can put an object on the side, and then it'll try to figure out whether it's a part of it, because it's variable distance. And it really assumes, the software assumes that the object is spinning around the center, and that's what it's scanning for.
So with the 3D printers, we found that things that have holes in them, like the holes have to be predictable, and you have to kind of design the object around where you want the holes to be in order for holes to work. How does this handle, like if there's a void in the center of that, can it look down into the object if that's a cup?
It can't. Okay. So it only is surface scanning on the outside. So they say that the best thing you can scan are things that are solid shapes, maybe curved, solid shapes with a flat texture. Even something like this, the Android figurine, notice that underneath its armpits right here, the body is blocked. So because the camera, when it's looking here, can't see what's underneath that arm, it's going to assume there's nothing there. It'll be hollow. There won't even be point data for that. It will see, as it's turning around, maybe a little shadowy edges here, and they'll try to fill in as much as possible, but any overhang is bad.
So what's the resolution finally of the model? So you get a point cloud.
Yes.
What's the resolution of that? How can you look at that and see what the object is?
Yeah, so I'll show you the software, which is a big part of it. It comes with the software. It's Windows only right now. That's why we're running on the Surface 3. I'm going to show you a new scan. So we'll use this example, and then in the software, I can click New Scan, and you have 3 basic presets. You have small, smooth, medium, or wide and detailed. And basically, what this tells you is first of all, how slow the rotation should be, and also how much information the laser is taking in, the camera is taking in per each of the double laser scans. With the smaller scans, the less detailed scans, what happens is it only takes about 5 minutes per entire rotation. So in 5 minutes or 7 minutes time, actually, it'll rotate once fully. And then if you have a taller object, for example, going back to the Android, this Android's probably a 2 height. If you want to look at the size of the Android, it's a 2 height. It's
scan?
a two height scan.
Okay, so the scans aren't equivalent to like 3D printing layers. It's not doing a couple of microns at a time.
No.
It's doing a couple of inches at a time?
A couple inches at a time.
Okay.
So for this, it'll scan up to here and give less detailed data on the top. And then with the stepper, it'll step up and then scan it again.
Is that checkerboard 1 height?
Half the checkerboard is 1 height. So right there.
Okay.
See,
so it's not quite enough to do...
Yeah, right there, that is 1 height.
Okay.
And that is about the 2nd height.
Interesting. Okay, so this is basically like in the beginning of Aliens, when they find Ripley's spaceship, and they come in with the big blue beam on the robot arm, and they map the entire room. That's what this is doing, just 2 inches at a time.
Exactly. I'm going to show you a quick demo right now. I'll use the small and smooth scan setting. You can actually go advanced and choose how many degrees it's turning, how much information. On the highly detailed scan, it's about 20 minutes per full rotation.
Okay.
And you have something that's tall, for example, this action figure here, that's going to be at least 3 heights. And so we're talking about over an hour of scanning just for this.
I mean, given the length of time that it takes things to 3D print things that are high detail, that doesn't seem out of the realm of possibility for me.
So there you go.
It's noisy.
It's very noisy. I've started it right now, and it's raised its first height, and you can see that there's the red laser on there right there. So
it looks like it's winking.
It's winking right there, and you can't actually see it on because it's covered right now.
on the platform.
But on the platform, you see a little bit of red. That is the laser line.
Okay, so it's
Right
just
there.
is the turntable spinning, or does it go incrementally? Does it go constantly, or just?
Okay, that was the calibration.
Okay.
So that was figuring out how high it has to do it, and now it's going, and now it's actually doing the scanning and turning. And if you look at the software, you can actually see the data being populated in real time in the software.
So the dots, and it's picking up colors too. It looks like,
It is,
or
it
at
picks
least
up colors and textures.
what it thinks of are the
Yep.
colors.
I can zoom in, and you can actually see that point data right here.
So okay, so you set it for smooth objects. So it's assuming. I assume this is generating a point cloud. This is not something that my 3D printer knows what to do with.
No, so, I want to talk about lighting conditions,
Okay.
objects and lighting conditions. It's actually really only loudest when it's moving the z-axis.
Okay.
But you can see like the point data right here. You can see that texture of that tie on the Android right there, and it's kind of really it's cool to see this object being scanned. You know, from a science fiction standpoint, this is kind of like the dream right now.
Can you set it high enough resolution that there's no gaps in the lines?
Yes. So
okay.
this is the very lowest resolution, and it'll actually, because it does the 2 lasers, it'll double up, and so it gets way more dense as
Okay.
time goes along. This is actually the lowest resolution.
And
right
this
now.
is, will it do multiple passes, or
It'll
will
do-
it?
yes,
Oh,
it'll
look,
do
it looks like the right is better than the left.
Yeah.
Okay.
So lighting conditions matters a lot.
Yeah.
I tested this in 3 different lighting conditions. one just kind of extreme outdoor condition next to an open window using natural light, that is terrible for 3D scanning. Even though, like, if you're a photographer, you know that just the difference between outdoor sunlight and any type of indoor, there's a huge difference in your, your light intensity, your light histograms, even though it might seem for your natural eye that things are just looking clear.
Right.
Don't scan this near an open window.
So I took this home and set it up on my dining room table and had absolutely no luck because I have a big giant window right next to the dining room table, and I just couldn't, it wouldn't go.
Yeah.
It was too dark at night and not bright enough during the daytime,
Right.
it seemed like.
I tried a diffuse setting, so with a frosted window, so you get like some of that even natural light in addition to indoor lighting, and that was okay, but the colors were all wrong. It's still not good. The best condition is actually right now. We are in the best possible scenario for 3D scanning.
Okay, so you needed like a video studio with a bunch of expensive lights.
What I did was actually just in my garage. And overnight, I turned on the lights, which I have fluorescent lights in my garage, and it was nice and even, no changes, and that gave me the best scans.
Okay.
We can actually maybe even leave this running in just a second, for just a second. See, so the 7 minutes it takes for it to scan, it's already getting a good data. Now you can tell, as I was pointing out,
there's big holes.
There's a big hole right there underneath its arm, and it's kind of the shadow texture. So right there, it doesn't even fill in this connection point.
So will it eventually come back and figure that out, or is that just dead information?
It will fill up as much as best it can, but it will never connect the dots between the inside of the body.
And that's because the laser just goes straight on to one point. It doesn't aim side to side, so it doesn't ever get the oblique angles.
Right. Okay. So I'm going to finish up the scan. I'm just going to pause it and go home. Finish it up. Finish scan. You can stop at any time if you want. You really want these things to stay steady. I'm going to save this later because I really don't want to do anything with it. In addition to the lighting, the type of object matters a lot. So I'm going to show you a couple objects just on the platform. Starting with the worst to the best. This is the worst. This is an action figure. I really wanted to scan an action figure. And
that's got a ton of crazy fine detail. And
ton of fine detail here, and also overhangs here. Confuse the hell out of it. Not only that, it performs really poorly with dark colors, with things like this.
Oh, so your TIE Fighter pilot is no good.
TIE Fighter pilot, which I thought would be a good size, it couldn't tell the difference between the gradients in dark.
So if you put these off center, does it theoretically get enough data on the point cloud? Because if it's not on the center axis, then you'll be able to see in those gaps, and it'll get a better view of that stuff. But I assume the software just gets confused at this point.
Software gets confused. It thinks that things on the outside might be over, and it stretches things out. You don't get a solid object.
When you're doing 3D printing, there are, at this point, a handful of really good options to do the slicing and printer control and all that stuff. Is that the case here, or does this only work with software provided by the people who make this scanner?
No, it works. It exports. So I'll tell you what happens when you get the file next.
But the thing that generates the point cloud is their closed software.
Yeah, they generate the point cloud, and the point cloud is very basic. It's going to be it's tuned to their cameras and their scanners. It's about 2,000 dots per scan per blink.
So I guess what I'm getting at is, if the software is tied to the printer, it's only going to improve as fast as those guys can work on the software, not like the open source 3D printer community where there's 4 different projects going at any given time and each one is getting better than constantly.
Right.
Okay.
And then, for example, the next best thing is something like the Android or like this bus, like head bus, where there's a good amount of detail and color. This scans pretty well. This scanned pretty well and gave me a pretty good result. I can actually show you, I think, if I have this file here, what this looked like.
This one, that one I would think looks pretty good, would do pretty well, although it looks like there's some gaps around the curl on his hair and all that stuff.
So this was this scan here.
Wow, that's really creepy.
And you can see the hair just did not do well because it doesn't do well with the black color. Yeah. But the flat texturing of this did pretty well. And this is at a high, this is a pretty high quality scan. So I go all the way in, like, that's a lot of detail right there.
Okay, so you have this point cloud, which is a...
Well, okay. Yeah. One more, couple more. Yep,
okay.
I'll give you a couple more examples. Next up, a flat shaded, like normal. So this is a 3D print.
And this is from the photogrammetry that Brandon
Yeah.
did last year or earlier this year for you.
Right. So this is a 3D print, and I scanned this, but I was afraid that it wouldn't scan well because it was too light.
How was this printed? What is this material? Do you remember?
This is SLA.
Okay.
And this one also scanned okay. You'll notice that in the bottom, in my scan, there are holes here. So
I did notice that.
yes, and you can tell that the color, when it moves up, it actually the color doesn't always match up perfectly.
Well, since you're probably not going to be using this with a color 3D printer, then
Yeah.
like if you have access to color 3D printers, this is a toy.
Right.
basically.
Color does not matter in these scans. It's really the geometry that matters the most. And then one final thing.
Hold on, you have a ring around the edge of this model. That's interesting.
Yeah,
Is
so
that
actually
just
it
picking
takes
up-
into the platform.
Okay.
It scans the platform well because it doesn't know, it doesn't know where the platform is.
Right.
And it's always going to want to get as much data as possible. And then finally, I'll give you one more example, and this is the best thing I scanned, which is very similar to that bus, except the texturing, the color, allowed it to recognize more of its detail.
Is this a sculpt or is this 3D printed too?
No, this is a cast. It's
Okay.
a vinyl cast. It's a Kid Robot cast.
We don't support communism at Tested, just for the record.
No, this is this, but it is Lenin. It's Party Lenin, and this scanned really well. The pink hue of this and the flat texture, it's not too shiny. That allowed it to give the laser and the camera as a lot of data.
So it seems like if you were sculpting stuff and using something that was dark but not black material, like Super Sculpey or something like that, then you could then take that and scan this in, and it might be a good way to get to import your model. So, okay, so
Okay,
you've generated a point cloud.
And so what can you do?
How long does it take at the highest resolution?
About like an hour and a half.
And that was 2 passes probably for that height, I would guess?
One pass.
1 pass for that one, okay.
Oh, no,
so,
two vertical passes.
okay.
Yes.
So figure 45 minutes per layer at the high resolution. Taller stuff obviously is going to take longer. How long did you do Zoidberg?
I did do Zoidberg, and that one took the longest time, and also it overwhelmed the computer in terms of the point cloud. So I can't actually analyze that on this computer.
You need a real computer.
Yeah.
Okay.
It uses a lot of memory. So let's look at this this vinyl figure, and you have the scan, and like you mentioned with the norm bust, it actually has some of the external stuff. So what can you do with the scan afterward? Well, you can clean it up. And so I'm going to go and you can see it actually took in some extra data from around it.
It looks like the hat's a little out of sync too,
Yeah.
or maybe just be the angle.
It's missing some data here, and that's just the lighting. It's got a little confused. So there's a clean button, and this is built into the software. Let's see if it loads properly. Clean. Oh, maybe it's not. There it goes. Okay. So there are 2 things you can do to clean. You can say crop all the points below a certain height.
Okay.
So if I like dramatically sketch this up, you can see all the red stuff.
So it's basically bringing a plane up from the ground and saying, okay, here we go. Let's not do anything below
Which is
here.
good, because you want to get rid of that platform.
Yes.
And maybe you want to create a flat bottom for manipulating the object.
So
We'll save that thought.
Okay.
So let's say I'm going to crop to here.
Making the flat bottom here is not a good idea, just for the record.
And then we want to maybe reduce the radius. And so if we know what the radius, like all this external stuff doesn't matter. And so you can see the circle comes in, and you can reduce the radius. Let's say I don't want these external stuff right here.
So if you converted this to a 3D model without doing this stuff, all those little specks would show up in the 3D model and confuse whatever you're going to try to do with it.
There's also an auto clean.
Okay.
And it has like thresholds, so it'll try to just remove extraneous bits of point data. So I will do that. It's gonna, depending on the detail of the model, it will take a while. Obviously, on this dual core processor, it's gonna be.
This is a desktop app. It just kind of looks like a Metro app.
And then what you can also do, so this is your model. You can save this and you can export this. You
Well,
can
this is still a mesh cloud. This is still a point cloud. It's not a model.
Right, and you can export it as a point cloud, a PLY file, an OBJ file. And these are files that free modeling applications like Blender, and there's a lot of good open source point cloud manipulation programs, they can read them.
As well as things, I assume, like Maya and 3D Studio Max and stuff like that.
Yep.
Or at least get plugins to read.
So you can export, XYZ point cloud, PLY polygon, but what's the big selling point of this, and of course the MakerBot also has the same feature, is that you can export it as a STL file, something that theoretically works with 3D printing.
STL is kind of the de facto source for models that you want to print. It's the file format that everybody uses to transfer files that you're not going to edit anymore typically.
But what the STL file is, it's not a point cloud. It's a mesh. It's
Well, so is the PLY for that matter.
It's a wireframe.
Okay.
And the wireframe, the conversion from the point cloud to the wireframe, that's the tricky stuff. That's what takes a lot of math, because the computer is stupid. It doesn't know, like, is that a nose? Do you care about that detail here? All it does is take these a cloud of dots and say, okay, maybe this is a straight line here. Maybe there's a plane there. Maybe this is an undercurve here.
It's just trying to convert a bunch of little points of light, a million points of light, into the Lenin's conical head.
Right. And so in the settings, when you convert to a mesh, there are actually two ways you can configure it. So right here, I've said meshing beta.
Can we switch back to there we go.
And before I convert the mesh, there are two parameters you can adjust. One is the Octree Depth, and what that means is how many little cubes this starts to analyze. So at 8, it's actually exponentially. So think about
is it cube, like it's breaking up the surface into a series of into a grid, basically?
Into a 3D grid, a matrix.
Okay.
If it was, for example, 4, you would do a slice vertically and a slice horizontally, and you'd have 8 cubes. Right? If you add another level of detail, then it slices all of those into 8 cubes. Each 8 becomes another 8, and then eventually you get like 150,000.
So presumably, the larger this number is, the better your eventual model is going to look, but also the longer it's going to take.
Much longer.
Okay.
By raising this to 10, it's going to take another 20 minutes.
Okay, so 20 minutes isn't that long for what we're talking about.
Sure.
Compared to the old days of 3D printing, where you would slice a model that was that size, it would take 2 hours to do the slice. I'm not upset about 20 minutes.
And then there's also degrees. So it's a lot of math. So it tells how the point cloud tells it whether it's use straight lines, 1 curved lines, 2 curved lines, 3 curved lines, or 4 curved lines to render out those to mesh that point cloud.
Okay.
Now you don't need to do that here. There's separate applications that will take point clouds and also do meshing.
So it will export the point cloud in a standard format if you're familiar with something else or have better tools available.
Right.
Okay, but what you did for me was you took this, I assume exported it here.
Yep.
We haven't tested any of those other point cloud applications.
Right. And here actually, that was relatively quick. This is a failure, because the mesh actually is no color. It's clearly no color. I don't think I can actually open a mesh file here. No. But what you get is something that looks like a flat 3D printed object.
Well, yeah, what I got was something that was theoretically a manifold 3D model.
Yeah.
And so you sent me a handful of these over the course of the last couple of weeks. I think you have some. I printed some of them.
Yeah, and we can show how good the print was.
I think there's 2 use cases for this. I think people are going to use this to scan stuff that they want to 3D print or then manipulate so they can 3D print it. I think people are also going to scan this to get art for things for 3D applications. So if you wanted to make a game and you wanted a quick way to get some 3D models in, and I don't know that this works if you're bad at 3D modeling. I think this might be a shortcut to get over the first hump, and then you can refine from there.
Or you can scale up, and that's something that you can do. Like, for example, you sculpt something small, import it, scan it, and then scale it up so you print it, and then now you get a large size version.
Or the other way as well. So I think this is a Totoro.
And this is a scaled down version. I scanned the Totoro sculpture. And you can kind of tell it has the texturing in here, but you had to do some stuff to make this work.
So yeah, one of the things I would recommend is that if you're scanning stuff on this, you should get a little square block that you can put on the base. Yep. So that it's scanned up off of the surface. It'll make the scan take longer, but it'll mean that you'll have more material to cut to make the flat plane. Because that was the first thing you had to do for everything that you sent me that was scanned.
You had to cut the flat plane.
In order to get a flat surface that was big enough to adhere to the platform and also be flat enough that it wouldn't wobble and break loose and make bad prints. I always had to run a plane through one of the first few layers of the print to get a flat surface to put the model on the print bed.
But this, I think it turned out pretty well. You can actually still make out some of the faces, the facial details here of the Totoro sculpture. I don't have the original, unfortunately, but I do have the other thing that we mentioned earlier, the 3D norm print. Now, this was the original.
So the thing I forgot to do, the thing we didn't do, was actually print the STL that you used to make that initial print on the same printer that I printed the scan on.
Yeah.
We'll do that, and I'll put it on the site at some point.
And this is a scan, and this is the print from the scan file.
Right, so you can see I had to cut off a little bit more of your shoulders to get it to work. And if you look on that mesh, then there was a gap on your left shoulder the other shoulder actually.
They had the fill.
That I had to fill, and I ended up just cutting off more than that because it was hard to do. So all of these came with some little speckles around, which I think you could probably have removed and maybe didn't know how to do at the time you sent me the STLs. I had to cut those out using either just slicing, or I opened them up in Meshmixer and then deleted a bunch of stuff. Filling in holes like that one in Meshmixer is pretty time consuming. Meshmixer is an Autodesk. I think it's either something they acquired or it's like an experiment. It's a really rough piece of software and it's kind of poorly documented, so you have to kind of just experiment to see what works. If you have access to a better piece of software or are good at using Blender in a way that I'm not, it was probably a better tool for doing what I was doing. I thought that turned out really well. You can't see it on the camera, but the resolution of the print versus the original SLA print is pretty good.
Yeah.
I mean, it's analogous to a fax machine,
Yes.
is what I would say.
Yes, and this is probably the best thing that was scanned and printed. The model, again, we showed the point cloud was the best from this flat textured vinyl sculpture.
I think you can see that there's a little bit of an error. You can see the error in the point cloud on the hat. It didn't line up quite right because of the angle that it's at.
But the facial details, I think, turned out really well. Those cheekbones, the eyes, the ears even.
He's immediately recognizable as Lennon.
And immediately recognizable as the original.
And you can see, but you can see that I had to cut a couple of millimeters off of the bottom. If you line up the left shoulder or right shoulder to the right shoulder, it's just a little bit lower on the printed one. I thought this was really promising. I know this is significant. Seems to me to be, even with the problems I had at home, seems to be a lot less fiddly than the early stages of 3D printing were, which I thought was kind of good, given that this is a relatively new thing.
Yeah, and this is super new. They just fulfilled their Indiegogo backers. They're selling this now for $580, I believe.
Seems like a reasonable price.
It's a reasonable price if you have some use for it. This is not something I think anyone should buy just because they want a 3D scanner. But if you have a 3D printer, if you have applications, as if you're sculpting, if you're a game designer, then maybe having one of these in your office, you can and you have experience turning point clouds into meshes in actual models, then you can actually this is serviceable.
If you're a game developer and want to make your game look like things from the real world, then this is a good way to do that, or at least to get started. At least it's worth exploring. I don't know that I would give it a ringing endorsement because we are not those guys.
No.
The last thing I found, the last tool that was really useful is a Microsoft tool called Netfabb with 2 B's. And what it does is it turns models that are non-manifold, meaning that they aren't watertight, that you can see the inside from the outside, into manifold models. And it's just a web form. You upload the STL, you wait 10 minutes, come back, and you can download the fixed STL. And that fixed most of the problems I had without having to use Meshmixer.
So for things like this Android, that hole we talked about in the armpits,
that one you would have to fix with Meshmixer.
Like if there's a small hole, the big holes you couldn't fix with that.
Big giant, like it fixed the hole in Lennon's hat, no problem. It wouldn't have fixed the hole in the Android guy, or if unpredictable things would have happened if you tried to do that, because it would have had this big several millimeter gap and not known what to do with it, and who knows what could have happened there. So,
well, there you go. This is the Matter and Form home 3D scanner.
It's $600, $580.
Yep, a little over $550. It's the first 3D scanner we've tested. I think that there are definitely more limits in 3D scanning technology than there are in 3D printing technology. It's not going to improve as readily as 3D printing technology did 4 years ago.
And there are lots of different approaches to 3D scanning too. I mean, we haven't gotten to test them yet because they're in kind of limited supply yet, but we've seen scanners that clip on to a Surface or an iPad and lets you capture that point cloud from things that are in the environment, not just things that are tiny and will fit on the turntable.
Or handheld ones that you walk around an object and it does like fast LiDAR scanning.
And I think that kind of stuff potentially is going to be more applicable to most people than something that just does small things that you can cut off and make flat and put on a surface.
Yeah, it's a really neat idea, and we're glad we could share this with you, even though I don't think most people are going to buy this right now. It's the future, 3D scanning.
You faxed a thing to me.
And then printing it out. Teleportation.
Yeah, faxing, Norm. See you guys next time.
Bye.